we want to find angle RPV. So that would be that angle between those two lines. They're not sides of the box, they're sides of a triangle. And if we look at this triangle, we want this angle in here, we'll call it theta. In order to find that angle, since this is a non-right triangle, we either need three sides to use the law of cosines, or we need an opposite pair of angle and side to use the law of sines. But we don't have that opposite pairing, so we might need to use the law of cosines. And we can use the law of cosines because we can find each of these side lengths using the Pythagorean theorem. Triangle PUV has a height of 3 and a length of 6, giving us a hypotenuse of square root of 45. Triangle RVW has a height of 3 and a base of 5. That gives us a hypotenuse square root of 34. And triangle PRQ has a base of 6, a height of 5, gives us a hypotenuse of square root 61. We're just using the Pythagorean theorem in each one of these. Now we know three sides, we're looking for an angle, we're going to use the law of cosines. So we're going to take the side opposite the angle, square root of 34, and square it. Equals the other two sides squared. So 45 plus 61 minus 2 times the adjacent sides. So 2 times square root of 61 times square root of 45, that is square root of 2745. And then cosine theta. So we're going to subtract 45 and 61 from both sides, leaving us with this. And we can solve this for theta by using the inverse cosine. And we get 46.60 degrees. Here we're measuring the elevation of a mountain based off of two angles measured out at sea. And we know this distance is 1473. We want to know what Tn is. In order to find Tn, I could use SOHCAHTOA because it's a right triangle, but I don't know any other side lengths in that triangle, which makes using SOHCAHTOA not effective at this point. But what I can figure out is I know what this angle up here is. I know what BTN is. That would be 90 minus 41.2, or 48.8 degrees. And I also know what angle ATN is. That would be 90 minus 29.7, or 11.5. Sorry, 60.3. Using those two, I also know what angle ATB is. Angle ATB is the difference of 60.3 and 48.8, or 11.5 degrees. Now I know an angle that's opposite a side in triangle ABT. Hence I can use the law of sines. Sine 11.5 over 1473 equals sine 29.7 over x, where x is the length of BT. And I can solve this and find that x is 3,660.62 meters. Now that I know BT, I can use SOHCAHTOA on triangle BTN. And I can say that in triangle BTN, the sine of 41.2 is equal to the opposite side, y, over the hypotenuse, 3,660.62. And when you solve this in your calculator, make sure you're using your answer feature, reusing the big long decimal, and you'll find that y is equal to 2,411.2 meters. That's the height of this mountain.